and I will be introducing debugging in Python for you. Now, I'm pretty sure it's not controversial to anyone that programming is hard. Programming also can lead to bugs, but we are going to take the spirit of Rear Admiral Grace Murray Hopper, who is responsible for discovering one of the most famous bugs. This is a moth that was in the relay panel of the Mark II computer. It's in the Smithsonian. You can take a look at it. Hopefully our bugs won't be quite as famous as that bug, but not all bugs are as obvious as a giant moth in a relay on an old computer. Sometimes it takes a little bit more, and debugging too is not just about fixing bugs in there. Lovely non sequitur there. It's not just about fixing bugs, it's also about figuring out what the code is actually doing in there. Because sometimes you get pieces of code, you're not exactly sure what the heck it's doing. You think it's doing one thing, but it's doing something completely different. So let's do a quick example. What does this code do? I'll give you a second to take a look at it and see what you think it's doing. All right? So let's execute it and see what it does. All right. Well, that's handy. It doesn't really do a whole lot that's visible. You think it's going to do something that's visible, but it doesn't. And you make this face. So what happened in there? Well, what happened is nothing is displayed. It doesn't actually get to this section of code here. And why is that? Well, one way to find out is the lowly print statement. How many people have used the print statement? Every hand should go up. It's a cheap and cheerful way of getting information out of there. There's no shame. You're among friends. So let's put a print statement right here and figure out what's happening there. And we have our other print statement there for when it's completed. So we now figure out what's going on. And we realize after that loop is ending, we're only hitting 4.75. We're not hitting the 20 that we might expect it to hit. So we learned a few things. Number one, print, and you have to have the parentheses around it because it's Python 3, will show the value of I. I is reset each time that it iterates through. So it's not actually changing the value of I, it's actually being reset each time that the range is generated. So it will never equal 20. We have dead code in there. So we figured that out by just doing a quick print statement. One way to do this, though, is to do logging. Now, instead of doing print, where it will print out to the console, you can then have a few more options of where that stuff gets directed to. So we start off by putting the logging initialization up in here, and we have it going to example.log. And then we have logging, debugging information in here. We put in a few things, beginning the loop and the end of the loop, and when the program is ended. So what does that look like? We're back first off to the silent running that we initially had. So we haven't really changed the output of the code. But now we have additional information about what the results are. So we can see that it started off the loop, and we see what was before printed out now is in the log file. And then we see that the loop ended and that it ended our program. So what does that get us? Well, number one, you have a nice, cheap, and cheerful way of turning debugging off and on. You can set log levels in there. So you don't have to modify all of the code that's around there in order to figure out what the log message, or where to pull out the log messages. So in production code, some people will do, put a print statement or something in there, and then suddenly you get a whole bunch of print statements that go out to places where you don't know where they're supposed to go. Now you have control over where those go. And you can figure out and filter out which ones are logged and which ones are silently ignored based on the logging level. So in here, I changed this. Instead of logging debug messages, it now logs info-related messages. So these will be turned off when it's all said and done.
Why didn't you print the value of I in your login for your loop then?
It's logged in here, but that's a debug.
So for somebody who doesn't really understand how Python's loop works, that could be useful information. It's not like C.
You're getting a little ahead of me on this.
Okay.
So, so we now have it back to semi-silent running. We just had the programming began and the programming ended. And I'll talk a little bit more about logging and the logging levels in a little bit. But in order to change it back over to showing debug, what I can do is I can change this program. And there's different ways of doing this with configuration files. This is just one way to do this, where you change the program in one spot from info to debug, and you get back all of the information about what's in that loop again. So then we're back to, here's info, here's all the debug messages, and here's the end of the program. Okay? So we can turn those on and off at will. And again, you can do it via configuration files or changing the program itself. It doesn't really matter. You're not actually trying to change the actual code itself, and forgetting where you have debug messages and where you have info messages. So let's try another example of this. Now this is a program that will take and read a sum of numbers from a file and then add them all together. So let's take a look and see what happens here. I run the code, and out comes an exception. Comes out and says, unsupported operand types for int and string. Okay, what's exactly happening here? Something screwball is going on. So we could log and print all of the data that's in there. That could be one way of doing this. However, if we take a look at all the list of numbers, we've got 2,000,001 numbers in there. Logging that would be a real pain in the butt. Number one, our output would be completely off. So there's another way to do this. And that would be to use, we could print off the first element off of here just to see what exactly is in there. That's one way of doing that. Instead of logging it, just print the first one. So let's see what that does. So we have, this is the first number that's in there, and what looks like a line feed. I'm not entirely sure what's going on in here. All right? But we're still getting our error out of there. All right. So that sort of gave us some information, but not quite. Let's try and do a little bit better. We could throw in and figure out what the type is, and that'll tell us, what will that give us? That will tell us, okay, we're getting a string in here. Well, we kind of knew that already. I mean, in this simple example, we kind of know, okay, yeah, it's an int and a string that is trying to combine. Can't do that. But print is pretty much a blunt instrument. It's only going to show you what the output, what is represented by Python. So you may or may not get useful information out of print, especially if you're printing like objects or something like that. It's not going to give you really good information. Logging isn't going to do a whole lot of good either. So if I throw all this instrumentation in here and then log out the number, what am I going to get? Well, it'll come back and give me a debug, and it's basically the same as if I had printed it. It's just I can throw it into a debug log now. It's like, okay, that sort of gives us some information. But what really will help us out is the debugger. Let me show you how to invoke the debugger. I'm going to go a little fast on this piece, but keep in mind, this is pretty much the rest of the presentation is on the debugger. So I start off the debugger by using -m pdb and then the sum of the numbers. I'm going to insert a breakpoint here where I'm getting the error. The sum is blah, blah, blah. All right? And then I will tell it to continue. C is for continue. So I've listed out the code. This shows where the breakpoint is. You see the little B over here? That's the breakpoint. And then I'll show you what happens after I hit continue. So it's going to print out the first number off of here. Or I'm sorry, I'm going to print off the list of the numbers in the first one, and our suspicion is confirmed. It's a string, and it's got a line feed at the very end of it. Ha! Now we have something useful. Now there's a cheat sheet if you want to follow along. I put in a slide with the cheat sheet. Unfortunately, that's really tiny type. So if you wanted to take a look at that real quick and play along, feel free. But the cheat sheet looks a little something like this. I'm sure all you eagle eyes are out there like, yeah. These are all the commands that are available, or at least most of the good commands that are available in the Python debugger. The URI again is github.com/nblock/pdb-cheat-sheet. All right, so let's talk again about invoking the debugger. There's two good ways to invoke the debugger. You use the Python command, Python 3, whichever you choose, mostly 3, -m, pdb, and then the file name that you're using. Or in the source code itself, and I'll show you an example of where this gets a little more interesting. You can do import PDB, semicolon, pdb.setTrace. And what that will do, and what's nice about that is that will allow you to, in separate files, like instead of trying to figure out for doing breakpoints, which file is this actually in, you can just insert it into the file itself. So it's a cheap and cheerful way of getting a breakpoint pretty easily in other code. Temperature warning. Oh, fantastic. Please don't die. So we put in, instead of putting the breakpoint, we can put the import PDB and then pdb.setTrace in the file itself. So I won't have to actually tell it, okay, this is where we're going to break. It will just automatically break. So if I can run the file directly, Python 3 sum of numbers, and then boom, it pops over into here, and we're back to our PDB debugger. Okay? Back to debugging the code. So let's change this. Instead of just appending the number, let's append the integer. That should fix the problem, right? Let's fix this. And when we run it, we're still back and getting a small problem here. So I run it through, tell it to continue, and it comes back with a traceback that says, invalid literal for int with the base 10, Bob. Apparently, Bob signed his work. Thanks a lot, Bob. So this is to show a conditional breakpoint. And what we can do is we can say, okay, break at line 13 and show me when the number equals Bob with a line feed in it.